Hello, Aruba.
Hello, ma'am. Assalamualaikum.
Walaikum salam. How are you?
I'm good. How are you?
I'm fine, thank you. Hello, Halima.
Assalamualaikum, ma'am.
Walaikum salam. How are you?
I'm fine, ma'am. Thank you. How are you?
Fine, thank you. Hello, Nashra.
Assalamualaikum, miss.
Walaikum salam. How are you, Nashra?
अल्हम्दुलिल्लाह मिस, आप बताएं.
I'm fine, thank you. Hello, Mahnur. Mahnur से बात हो गई हमारी? नहीं. Hello, Nimra.
Assalamualaikum, ma'am.
Walaikum salam. How are you?
I'm good, ma'am.
Good. Mahnur, are you there?
Yes, ma'am.
Good.
Good morning, ma'am.
Hello, Elia.
Hello, ma'am.
How are you?
Fine, ma'am.
Good.
How are you, ma'am?
Fine, thank you. Okay. So you guys have received the email about the online classes, have you? Did you get any communication from FCC?
No, ma'am.
No? Okay, anyway, we've got a communication that we will be having online classes till 30th of April. I suppose you will also get this communicated. So please stay safe and take care. And we can continue online. ठीक है? Okay, fine. So let's start. So what were we studying last time? We were talking about जी क्या पढ़ रहे थे हम last time? Who would like to give us a small recap? Yes. Come on. Yes, Nimra, would you like to tell us something about what we studied last time? Nimra, are you there? Who would like to say something? What about you, Elia?
मैम लास्ट टाइम हमने इलेक्ट्रिसिटी के बारे में पढ़ा था. इलेक्ट्रिसिटी पोटेंशियल क्या होता है, इलेक्ट्रिसिटी करंट, इलेक्ट्रिसिटी फील्ड, इलेक्ट्रिक फील्ड वगैरह, इन सब चीज़ों के बारे में हमने पढ़ा था.
Current,
और ये
field, right?
और मैम हमने ये इसका एक ये फॉर्मूला से एक क्वेश्चन सॉल्व करने की कोशिश की थी लास्ट में.
Very good. Okay, Aruba, can you continue? What was the formula we were talking about? Aruba?
Yes, ma'am.
बेटा क्या formula था?
Ma'am, I don't remember.
You don't remember. So please make sure that you study in the evening after every class. ठीक है ना?
मैम Ohm's law था.
Yes,
law.
very
V
good.
is equal
So,
IR.
very good. Ohm's law is very important. It's very simple and it's very important. That's right. Okay. Yes, Fahad, would you like to tell us what V is? V means? Yes, Fahad. Fahad, are you there?
Ma'am, V is the voltage measured.
Very good. V is the voltage. Okay, what is I? Fahad, what is I?
Ma'am, I is the current.
Current. Very good. And what is R? Fahad?
Ma'am, R resistance.
Resistance. Okay,
Resistance.
good. Okay, so Halima, can you tell us what are the units of voltage? The units of voltage is? Halima? Halima, are you there? She doesn't seem to be there. Okay, Mahnur, would you like to tell us?
Yes, ma'am, I am. I'm sorry, my mic.
Okay, so what is the unit of voltage?
Joule,
What is the unit of current?
एम्पेयर
कौन बोला?
एलिया में
Area, अच्छा. The unit of current is an ampere. Okay. Elia, abhi aap na bolo. Let me talk to other students. Okay. Halima, would you tell us the unit of resistance? Okay. Let's talk to Mahnur. Mahnur,
Joule.
आपका हर चीज का answer is not joules, right? Okay. Mahnur, can you please answer this? Hello. Mahnur,
Yes, ma'am.
what is the unit of resistance?
Ma'am, Ohm.
Ohm. Good. What is the symbol for an ohm?
Ma'am,
What is the symbol for ampere?
ma'am, A.
Capital A, right? And what is the unit of voltage?
Ma'am, V.
V stands for
Volt.
volts, right? Good. So volts and V, and now ohm. What is the symbol for this, right? Yes. We don't have a Minahil in this class. There is someone with the name of Minahil trying to join the class, but we don't have Minahil in the class, right? So I'm not going to let this person join the class. You have to have your proper name and only students can join the class, right? Okay, yes. Who will tell me the symbol for ohm?
Ma'am, I know the symbol, but I don't know how to explain it. Like,
This is Ahmed Farooq. Ji beta, you don't know the name
ma'am,
of the symbol, right? We talked about it in the last class. So this symbol is the Greek symbol. This is called an omega. Okay, so you know that we use alphabets for symbols, we use Greek letters for symbols. We also have conventions regarding where we are going to use capital letters and where we are going to use small
letter.
हाँ ठीक है. So please आप लोग after every class, like I said, अगर आप 1 घंटा शाम को पढ़ लेंगे तो it will be a stress-free preparation, plus you will not panic in the end, plus you will perform well. Okay, so please don't wait till your deadlines to try to prepare, because then you will get confused. Is that clear? आप लोग पढ़ा करें. After every class in the evening, please study, and also, and then it will be fresh in your mind. The discussion in the class will be fresh in your mind, and then when you study on your own, it will be reinforced. And then this is the best way to study without any stress, without any burden, and you don't have to put in too much effort as well. And on Thursdays, like I said, you should practice the lab material. Okay. So let me see. I am going to send a message, but where is my message? So where is the message? I cannot find my message here. Meeting info on height names, share sound. Okay, so anyway, so this was a recap of the class that we had. I'm going to take the attendance now. So Ahmed Hassan, he's not present. Fahad Ahmed.
Yes, ma'am.
Okay. Aisha is not there. Musa is not there, right? Mahnoor.
Yes, ma'am.
Okay. And Nimra.
Yes, ma'am.
Okay. Azad, Sayyid Azad Asad is not there. Farooq, Ahmed Farooq.
Yes, ma'am.
Okay. Awais Khawer Gil. No. Laiba. No. Sahib Khan. Yes.
Present, ma'am.
Okay. Elia.
Yes, ma'am.
Amna Maham is not with us. Nashra.
Yes, ma'am.
Aruba.
Yes, ma'am.
Okay. Halima.
Yes, ma'am.
Okay. Let me send a message. Okay. Who is this? Sahib Khan. Acha. Okay. And Halima.
Yes, ma'am.
Nawab.
Present.
Sumavi Tahir. She's not here. And Saud Rafaqat.
Present, ma'am.
Good. Okay, so we continue from here. Now I'm going to share the book with you. Okay. So this is where we were last time. We'll continue from here. We'll talk about electrical circuits today. Now we are all using circuits as we know. And one of the basic requirements for a circuit is that it should have a power source, right? So in order to have a power source, which we have been calling a source of voltage, a source of EMF, so we need a battery, right? It can be in the form of the cells that you use in small devices like calculators and clocks and so on, or it can be the alternating current that we have from the main power supply, or it can be the battery that you have in your car. But anyway, any circuit will need a battery. Okay, this is an important component. There will be no current in a circuit if you don't have a battery. Another important component would be a switch. Why do we need switch in a circuit? So that's a question to all of you. And why is it important? And then when you do lab practicals also, this is very important to have a switch in your circuit when you make circuits, right? Again, current will only flow when the switch is closed, and it will not flow when the switch is open. So these are some basic principles of electrical circuits. Now, current and voltage in circuits, we can see from this diagram that we spoke in the last class, that in order to measure current, we use a device which is known as an ammeter. And in order to measure a voltage, we use a device which is called a voltmeter. And also you will see when you go in the lab or when you even perform virtual experiments, you will see that we, instead of having these separately, we sometimes have a multimeter. A multimeter is a small device where we have all these meters in one device. So anyway, but you should know to make the settings, how you're going to do the settings for measuring current and how you're going to do the settings for measuring voltage. And also another thing to notice in this circuit is we have two types of circuits. We have series circuits and we have parallel circuits. So series means that one component is connected after the other component and they're connected in a series like this. So this is called series. And parallel means that the components are connected in parallel like this, which means that the two ends of the component all correspond to the same voltage. Okay, so we will study some rules and laws about this. Again, when you notice this diagram, one thing to notice is that an ammeter is a device that's always connected in parallel with the circuit to measure current, and voltmeter is a device that's connected in parallel in order to measure the voltage across a component. For example, in this case, you can see that the voltmeter is connected in parallel to a resistor. So you can measure the voltage across.
I'm sorry for interrupting you, ma'am, but
Yep.
Amna is texting in the group. She is trying to connect the class from her
बेटा
sister's
मैंने
phone. And Minahal is
कौन बोल रहा है? कौन बोला?
मैम मैं बोल रहा था.
नाम बताओ
अहमद.
ना बेटा. What's your name?
Ahmed, ma'am. Ahmed Farooq.
Ahmed Farooq. Okay, so I sent a message in the waiting room that students have to display their proper names, only then they will be allowed to join the meeting. ठीक है ना? This is something I've
Okay.
explained to you from the beginning. I sent a message to this person because the name that I can see is Minahil Akhtar. I don't know Minahil Akhtar. She's not in my class. Okay, and you know, another small tip for all you guys is that it's very easy to change your name even if you're using somebody's device. Okay, you can just right click on the icon, okay, and for the user ID, and you can immediately change your name at that time. It's not difficult to change the name. So she has to display a proper name before I let her into the class. Okay, that's a rule for everyone. Okay, so yeah, current in a complex circuit. So we can have simple circuits, we can have complex circuits. I just talked to you about two types of circuits, which are series and parallel, but then we can also have a circuit in which we have a combination of series and parallel. As you can see in this case, you can see that some components are connected in series and some components are connected in parallel. And then you can do the calculations for how you can find the various parameters relating to this. For example, there's a very important rule that's known as the Kirchhoff's rule. And according to this rule, at any junction, the sum of all currents entering the junction must be equal to the sum of all currents leaving the junction. This means that, for example, when you have this battery and this circuit, let's say the current passing from here is IC, the circuit current, and then this current divides into two parts, I1 and I2, and then it will then again combine together, and the current here will again be IC. So the current entering the junction should be equal to the current leaving the junction. This is known as Kirchhoff's rule, and you can see it here that I1 plus I2 is equal to IC. So this is one of the rules, and you can see that this current is measured by the ammeter. So the AC is measuring the circuit current here, and then A1 and A2 are the ammeters measuring the current in these branches, and then finally you can measure again and see what the current is at whatever point you want. So this is a very good explanation of these series and parallel circuits. Like I just told you, something connected after another thing is called a series circuit. As you know that the symbol for resistance we can either do it like this or we can draw it like this. So it means they're coming one after the other. The second is the parallel, and parallel means that the two ends of one component are connected to the two ends of the other component in parallel like this. So these are the examples of these circuits, and there are some important rules again about this. And these rules have been given over here. Resistors in series, as we have just seen, if two or more resistors are connected in series, the current through both of them is the same. So when we have components in series, the current is the same, I is the same. This is an important point you should remember, okay? However, the voltage drops as it goes across the resistor. The larger resistor usually using proportionally more energy. So according to Ohm's law, right? V is equal to IR. If you know I and you know R, you can find V. So the voltage here will be V1 and the voltage here will be V2 if this is R1 and this is R2. But the current I1 and I2 will be equal. So I1 is equal to I2 is equal to I. This is the case for a series combination. Okay, now if we talk about components in parallel, here we know that the current may flow through each branch of the circuit. A larger current flows through the lower resistance arm of the circuit according again to Ohm's law. And okay. And an important point in this case is that the voltage will remain the same. Okay, it's not written here, but this is the case. So for example, in a parallel circuit, they have said that I1 plus I2, yes, here you have this written over here. So the current is divided among the two components, the voltage remains the same. This is an important point for parallel circuit. And again, using the same Ohm's law, we can calculate this. For example, if this is R1 and this is R2, then the corresponding current would be I1 and I2, and the corresponding voltage will be V1 and V2. But V will remain the same. For parallel circuit, V is the same. In this case, I is the same. In this case, V is the same. But I will be, so we have V1 is equal to V2 is equal to V, whereas I1 or the total circuit current is equal to I1 plus I2. So these are the opposite of each other. You can notice this over here. Okay, so here you have some calculations and some examples of what I've just explained. So again, the way to find these values is you will know the two values and you can find the third one using the simple Ohm's law that we were talking about in the last class. So this is a very simple law, but it can give you a lot of information. And this is an example how you can do this. Total, okay, again, resistance in a series circuit, the total resistance is equal to the sum of the resistances, okay? But in a parallel circuit, the total resistance is not equal to the sum, rather there's a formula, and you can see the derivation of this formula. So the total resistance is bounded by this formula. So that this is another difference you can see. Okay. Let's do a small problem here. Last time the problem where we ended, there was a mistake in that problem. I hope you guys have corrected it at home. Okay. And now we are going to apply these concepts to this small circuit, and I will give you a point to whoever gives me the correct solution. So I give you 1 minute to solve this. Okay. So please solve this. Give me your name when you've solved it. Okay, Amna Maham is there now. Okay, good. Yes, who would like to give us the answer to start with and then the solution? A circuit contains 200 ohm globes. Globes means maybe light bulbs, okay, connected in series to a battery as is shown in the figure. What is the total circuit resistance? Who would like to give me the answer for this? You will get a point for this. This is class participation points. Yes.
Ma'am, Aruba.
Aruba, yes, Aruba.
200 ohms.
So the answer is 200 ohms. Can you explain how you got it, Aruba?
Yes, ma'am, because they're in a series.
They are in a
So we
series.
add
So
them.
if this is R1, this is R2, the total circuit resistance is RC is equal to R1 plus R2. And therefore, this is equal to 100 plus 100, which is equal to 200 ohm. Remember to write the units. Very good. So Aruba gets a point. Okay. Right. So from here now, I would like someone to solve the second one. And again, I'll give a point for this. Who would like to solve the second one? Yes. So in this case, we have a parallel combination, right? And therefore, the formula we will use is the same one that we discussed. 1 over RC is equal to 1 over R1 plus 1 over R2. So if this is R1 and this is R2, we can find the total resistance using this formula. Okay, so let's go forward. We can do these problems later on, or you can practice them at home. And we talked about the meters used for measuring current and voltage, the ammeter and the voltmeter. So this is an explanation of these meters. Another concept that we deal with when we are talking about electricity and current and so on is the concept of power, electrical power. We have two kinds of power. We have the gravitational mechanical power concept that we studied when we were doing the previous chapter. But in this chapter, since we're talking about electrical circuits, there's a power associated. And as we discussed last time, whenever you buy an electrical device, there's always a power mentioned on it, right? Whenever you go to buy a bulb, for example, they will ask you, what power bulb do you want? So what is the unit of power? Is watts, W, capital W, okay? So you have 60-watt bulb and you have 20-watt bulb and so on. How do we define power? Power is defined by these formulas, right? This is the formula where Q is the charge and this V is the voltage and T is the current. So it is, it can be defined in this way, and it can also be defined as a product of current and voltage. Because Q over T, you know, is equal to I. We studied this in the beginning of the chapter. The Q over T is equal to I. So we can write it in as a product, and we can also write it in terms of resistance. So it can also be written in this way. Depending on the problem that you have to solve, you can use the relevant formula. And we know that power is also related to energy. Okay, so electrical power carries energy, and which is defined, which can be defined by this. And here you can have the formula, and the unit for energy is joule. You know, in the beginning of the class, there was a student who was saying joule is the unit for current or voltage. It's not the unit for current or voltage, it's the unit of energy. That's why you can see the joule here, okay, because this is energy per unit time, okay, because power is defined as energy per unit time, and then you can use the joule. Okay, so these are again problems related to these. And when we talk about the circuits we have at home, one of the important components of these circuits is the fuse, as you all know. The fuse is a device that is for safety. If the, for example, current exceeds a certain value, the fuse wire will disconnect and it will disconnect the circuit so that there's no damage done to the circuit. So this is an important concept, and you can read about this. Now, this is again an explanation of how the household power and electrical system works. So we have certain conventions in this regard. You can see a household circuit here. You can see that there's an active wire, a live wire, a neutral passive wire, a ground wire. And there are specific colors that are given to these wires so that it's easy to identify them. And of course, you should not touch the circuit if you don't understand how it works and you don't know about the safety of this. Safety is very important for when working with electrical circuits. So you should first familiar. We all know that you should never touch something from which there's an electrical current passing, and there's, because there are some simple rules that have to be followed. For example, one of the rules is we are all using electrical appliances, but we should learn how to use them safely. So we should not overload plugs or extension boards. You should know that. And also you should know that there are some devices that require a high power, like the heater or like the iron, so they should not be connected with other things at the same time. Okay, so again, we know that plugs should be inserted properly. Of course, we should avoid children going near these plugs. And we know that when we are not using something, we should always unplug it. But some people have the habit of keeping everything plugged in all the time. So you might, that's not safe. Also, you might be degrading the device that you are plugging in all the time, right? Again, we know that you should not have any water or moisture near your electrical circuits. That can lead to short circuiting, and that can lead to fire and a lot of damage. You guys might remember what happened in Hafiz Center, right? So we should be very careful. And again, if a wire is broken or it's old, please replace it immediately. Don't use it, because then it becomes a danger, right? Now, this, for example, if someone has an electrical shock, what will be the biological effects of that shock to your body? Of course, it depends on the current that's flowing, right? It depends on the time for which there's an exposure. It depends on the path, on the frequency, and on the area of the contact. Both AC and DC power supplies can be very dangerous, so we have to be careful about that. And this is an explanation about this. So this is not to be taken lightly. Everyone should be very careful when using these devices. Okay. Right. So now let's come to a problem and use these concepts that we have just studied. There was a problem that this was on page 39. So let's look at this problem on page 39. Yes. Yeah. Okay, so now again, I would like to invite you to solve this problem, and I will give you a point for solving it. Let's start with this one. So we have a circuit which is given here in figure 3.44. And the first part of this question is, what is the circuit current flowing in the circuit? So I would invite you guys to solve this, and then I'll give you a point for this. Please tell me your name when you tell me the answer, okay?
Ma'am, Amna Maham.
Amna, yes, Amna. Then let's talk to Amna. Okay, Amna, tell me.
The current flowing in the circuit is 5 volt.
5 volt is the current flowing in the circuit, Amna. Can you explain this?
Ma'am, because in the figure with the battery is of 5 volt.
Okay. Anyone else? Would someone else like to explain this?
Ma'am,
Ma'am,
5 volts is the voltage, not the current.
Yeah. Ma'am, the current is 75 amperes.
Who is speaking now?
Ahmed Farooq.
Ahmed Farooq, what did you say? The current is?
Ma'am, it's 75 ampere.
70. How did you calculate this?
Ma'am, through formula I is equal to VR. The total resistance is 15
V is equal to
ohms.
IR and I is equal to
Oh, sorry, yeah.
V over R.
V
Okay.
over R.
Okay, so this is equal to?
Ma'am, V 5 over 15.
5 over 15, and therefore?
Ma'am, it's 0.3 amperes.
तो तुमने मुझे 75 क्यों बताया?
मैम मैंने फॉर्मूला उल्टा करके मल्टीप्लाई कर दिया था, सॉरी माय बैड.
ये गलत हो गया ना? अच्छा, so
Yes, ma'am.
0.3 amperes. Okay, do we all agree with this? Let's see. Yes,
Yes.
it's correct. So Ahmed Farooq gets a point, right? Please look at the next part. Ahmed Farooq, yes. The next part is what is the voltage across the 10 ohm resistor? Who will solve this? So Amna, this was wrong. Okay. Who would solve the second part? What is the voltage across the 10 ohm resistor? Yes. What is the voltage across the 10 ohm resistor? Yes, please.
Nawab. Ma'am, voltage 3.3 volts हो.
Nawab, can you explain? Just a moment, let me write it. So we are talking about, Nawab says the answer for B part is
3
what?
volts.
And the answer and the reason is
करंट अभी हमने फाइंड किया और वो थ्रू आउट द सर्किट सेम रहता है तो उसको रेजिस्टेंस से मल्टीप्लाई करके वोल्टेज
so we are using Ohm's law. We know the current is 0.3 multiplied by the resistance which is 10 and therefore this is 3. और अगर ये 0.33 था तो फिर ये 3.3 हो जाए. So 3 and 3.3 both are correct, है ना? So Nawab gets a point. ठीक है? Okay. So Nawab gets a point. Please do the next part. I would like to make an announcement, and for that purpose, I'm going to share the schedule with you. And like you're already familiar with this, this is also on Moodle. I've been announcing it. So the assessment plan, can you see the assessment plan?
Yes, ma'am.
Okay.
Yes, ma'am.
So we have done this one and we have done this one. Now we are going to do the midterm, and the date for the midterm is 14th, and 14th, as you know, is next week, right? So this is, I want you to prepare for this. This is going to be from the first 2 chapters and it should be well prepared. And also this time I would like you guys to have, to show me your working, which means you're supposed to have blank sheets with you and a paper and a calculator. Don't have anything else in the room. And you will show me what you're doing by switching on your camera on the Zoom meeting while you're doing this. This will happen during class time. And then you will scan the working. And after you will send me the scans on Moodle. So scan of the working is required. Plus you will also switch on Zoom with camera during the class time while you're doing this. Okay. So this is an important announcement. Please prepare for this, chapter 1 and chapter 2. Okay.
Okay, ma'am.
Okay, no, so
Okay.
now, okay, great. So the meeting is now going to end, and please prepare and give a good examination, and you're well familiar with the content that we have covered. Okay, so take care. Bye-bye.
Bye-bye. Bye-bye, ma'am.
Bye.
Ma'am,
Okay.
Yes, the meeting is going to end. Jaldi bolo.
मैम आमना आप प्लीज मेरी ये जो है ना अटेंडेंस लगा देंगी. मेरा कनेक्शन इशू था, पता नहीं आज लैपटॉप को क्या मसला था.
Okay. Okay, bye.
थैंक यू. अल्लाह हाफिज.
Allah Hafiz.